Dear friends, so in this session I'm going to discuss about the construction of the cam profile. So the cam rotates in the anti-clockwise direction. So the knife edge follower and the cam follower motion is uniform acceleration for the ascending and the SHM for the descending. Okay, let's see the conditions. A cam is to give the following motion to a knife edge follower. Then to raise the follower through 30 millimeter, okay, the height of the displacement 30 millimeter with uniform acceleration retardation during 120 degree of the cam, that is ascending UARM with the 120 degree cam rotation, dwell for the next 30 degree, then lower the follower with the SHM during the next 90 degree of rotation of the cam, dwell for the rest of the cam rotation. Use the following data to draw the cam profile. Minimum radius of the cam is 30 mm, that is base circle radius is 30 mm. The speed is 800 rpm in the counterclockwise direction. So this the cam rotates in the anti-clockwise direction. Follower axis is in line. So also draw the displacement, velocity and acceleration diagrams for the motion of the follower in one complete rotation. Okay. Before constructing the cam profile, so to draw the displacement diagram, draw a rectangle of height is equal to the height of the displacement, that is 30 mm, length is equal to the ascending and the descending, that is 6 cm to 6. Then divide the ascending and descending into 6 parts and draw lines from these points, that is totally 12 points, 0 to 6, 7 to 12. Okay, divide the vertical since ascending is uniform acceleration retardation motion, divide the vertical line drawn from the third division into 6 equal parts. Okay, height of this into 6 parts, that is 5 mm each, and then join these to the lower 3 points to the lower left corner and top 3 points to the top right corner. Okay, that is 0 to 1 2 3 and 5 6 to the 0.6 or the 4 5 to the 0.6. Okay, then the intersection of points of these are the required point, or they mark the point A B C D etc. and join these points to the smooth curve, that is total 6 points will get, and join this to the smooth curve, that is your uniform acceleration retardation motion. Next the descending is SHM. Okay, draw a semicircle. So the displacement height as a diameter in the rightmost line of the rectangle here. This harmonic circle, divide the semicircle into equal parts. Okay, 6 parts. Okay, that is 30 degree each. Then project these points in the semicircle to the corresponding divisions of the cam displacement interval. Then the intersection of these points are the required points, and join these points to the smooth curve. Then you will get this simple harmonic curve. This is a simple harmonic curve. This is a displacement diagram, uniform acceleration retardation motion for the ascending and the descending simple harmonic motion. Next, cam profile construction. Here first draw the base circle of radius 30 mm. Draw a circle of radius equal to 30 mm. That is the base circle. Since the cam rotates in the anti-clockwise direction. Okay, so then the mark the point O as the center of the base circle. Then draw a vertical line, vertical axis. Okay, vertical axis. Then so how to mark the angles, ascending, descending, etc. Since the cam rotates in the anti-clockwise direction, so to mark the angles in the clockwise direction, opposite direction. Okay, opposite direction, that is since the cam rotates in the anti-clockwise and counterclockwise direction, from the vertical position, that is vertical line O0, this line. Okay, from this vertical position, mark the angles. Ascending is 120 degree, then the dwell 30 degree, then 90 degree descending, and remaining 120 for the dwell. Okay, this is so to draw in the clockwise direction. If the cam rotates in the anti-clockwise direction, then the angle should be marked in the clockwise direction. If the cam rotates in the clockwise direction, so to mark the angle in the anti-clockwise direction, opposite. Okay, ascending 12, descending and the 12. Then divide the ascending and descending angles into same number of equal parts. Okay, that is 6 parts, 6 divisions, that is 0 to 6 and 6 to 12, that is totally 12 points. Okay, 0 to 6 and 6 to 12 in the clockwise direction. Okay, the marking also in the clockwise direction, 1 2 3 4 5 6, then 6 7 8 9 10 11 12. Okay, then join these points in the center of the cam. Okay, and extend these lines. So it is a knife edge follower. Okay, and it is not offset. Okay, it is a the inline. The cam and the follower are in the same line, inline lines. Then on these lines, take the distance equal to the lift of the follower beyond the circumference of the base circle and mark the points here. So 1A, 2B, 3C, 4D, 5E, 6F, etc. These points. Okay. From the your displacement diagram, mark these points on the cam profile, say above the base circle. Above the base circle. Okay. Then join these points with a smooth curve. Draw a smooth curve joining these points. This is the required cam profile. Okay, this is the required. As the cam rotates in the anti-clockwise direction, so it will. So first is it is ascending, then the dwell, descending, dwell. Okay, this is the required cam profile. Then regarding the velocity and acceleration follower, okay, the displacement height is 30 millimeter. Theta O, that is outward angle, is 120 degree. Theta 12 is 30 degree. Theta in the return stroke, it is 90 degree. Theta 12 2 is 120 degree. Then the radius of base circle is 30 millimeter and the speed is 800 rpm. So it should be converted into the omega, that is 2 pi n by 60. 83.7 radian per second is the angular velocity of the cam. Then the maximum velocity of the follower during the lift, it is 2s into omega by theta naught. Okay, 2s into omega by theta naught. Theta naught is 120 degree. It should be converted to the radius, that is pi by 180. That is maximum velocity during the output stroke is 2.4 meter per second. Then maximum acceleration for the follower during the lift, the outstroke is 4s omega square by theta naught square, that is for the uniform acceleration retardation motion. This is the equation for the uniform acceleration and retardation motion. It is 192 meter per second square. Okay, velocity is 2.4 meter per second and acceleration is 192 meter per second square. Then the maximum velocity and acceleration during the return stroke. In the return stroke, it is SHM. The velocity is pi s divided by 2 theta r into omega. Okay, pi omega into 2 theta by omega s divided by 2 theta r. Return stroke is angle is 90 degree. 90 degree into convert into radius, 90 into pi by 180. This 2.5 meter per second. Acceleration is pi square omega square s divided by 2 theta r square. Okay, that is 420 meter per second square. And this is a your ascending is uniform acceleration. This is a displacement diagram. This is a uniform acceleration retardation motion. It's a triangular shape. Maximum at the middle. Then here it in the sine curve for the SHM. Similarly here for the acceleration. Okay, acceleration is a linear in the uniform acceleration retardation motion, whereas in the it is a cosine curve for the SHM. This is about the velocity and acceleration. Now I will explain the steps to draw the cam profile for the anti-clockwise direction of the cam rotation. Construct the displacement diagram as per the given follower motion. Draw the base circle. Then here the cam rotates in the anti-clockwise direction. From the vertical direction, mark angles ascending, dwell, descending and dwell in the clockwise direction. Divide the ascending and descending angle into same number of equal parts as is done in the displacement diagram, usually 6 divisions. Join these points to the center of the cam and extend these lines. On these lines, take distances equal to the lift of the follower beyond the circumference of the base circle. Then draw a smooth curve joining these points. This is the required cam profile. Okay. Thank you.